movies in National Geographic and all. Okay, that something is being done and it's being shown in a particular way. Okay, so this is a simulation. Like for example, a truck falls from the top of a mountain. So how it is going to fall? Okay, so this is an example of a simulation. Okay, so simulation not only done on the system, that is the computer, using graphics and all, that is one of the types. And there are other types also where we are looking into types as well as the manual part of it. Okay, so we are solving some problems. There is something called as Monte Carlo simulation, which we will be using, like the problems we'll be seeing today. Okay, so simulation in the sense, this is the definition of the simulation that you can see on the screen. Simulation is a process of designing a model of a real system and conducting experiments with this particular model for the purpose of understanding the behavior for the operation of the system. So what does this mean? So this means we are building that particular simulation. Okay, then we are changing the inputs. So when we change the inputs, what does the particular system, the simulation what you have made, how will it react? Okay, so this is what we want to see. That is what is being told here. It's the process of designing a model of a real system. So why we do this? For example, like a rocket engine. Okay, so rocket engine costs in crores together. So we cannot make it just like that and start testing. So simulations are done so that we are not losing the parts. We are not losing too much of money on it. So there'll very many parameters, like fuel is less, like fuel is more. If certain system fails, how will it work? So all these things they simulate basically. Okay, before going to the making of the real part. Okay, and then testing it. Before that, there will be simulations done, and variations in that particular simulation can be done. Okay, it is easily like changed. It could be easily changed according to your requirement. Then they'll test it again in the simulation itself. Okay, then after that, everything when they see is it is okay, then they'll make the actual part. Then they'll try testing it. So then again there will be some issues which will be they'll be noting it down. Then again they'll put it in that particular simulation. Then again they'll run the simulations. So for the simulations to run, it is very much easy. Okay, like for example 20, 30, like for example take the rocket engine only. So you cannot send 30 rockets or 40 rockets to the what you call the atmosphere and we cannot test them. So what they do? They'll do the simulation. So that is what is simulation here. Okay, then coming to types of simulation. So deterministic and probabilistic simulations. I was talking to you about the different types. So first one is deterministic and probabilistic simulation. So what does this tell you? So the deterministic simulation is used when a process is very complex or exists in multiple stages with complicated procedural interactions between them. And means when it is having multiple stages like rocket engines. So there are multiple stages where different engines are running. Okay, so this is one of the examples where multiple stages are there and it is very complex. Okay, and the system is working with each other. So at that particular time, we are using the deterministic and probabilistic simulation. Okay, so then next comes the time dependent and time independent simulation. So here time is important. Sometime, like for example in some of the simulations the time is very important. Timing is very important. Like for example when time is not that much, in the sense it is independent of time. For example, you need some parts. You know that okay, you need 3 parts per day. Okay, but you don't know when exactly you require that particular 3 parts. You know you are using 3 parts. Okay, that means you are making 3 models. Or like for example take manufacturing of car. Okay, you manufacture cars a day. Okay, so certain system or a certain part which somebody is sending you, he knows that you need 3 systems for that particular day, but he cannot tell you like when, or he cannot predict that when exactly you know need those 3 systems. You need it at a time, you need it one by one. So you never know. So that is the time independent situation. So time dependent situation in a sense, like example take, you are standing in a queue, or for example you are going to a hospital where there is a big queue. They'll tell you, right, number laga ke jao. So you want to know, like you'll ask them, right, like mera number kab aayega, right? So it could be like after an hour, after 2 hours, depending upon the type of patient, for what you are looking at. So how long that doctor is taking per patient. So all these things. So here you need the exact time. Okay, like exact in the sense a little bit here and there is okay, like especially in that particular queue example. So you go to the doctor and he says okay, ek ded ghanta ho jayega, so one and a half hour it may take. So you can come after 1 hour or 1 hour 15 minutes. So if your turn is there, we'll allow you, or you need to wait for another 10 15 minutes. So okay, so that is the time independent and the time dependent simulation. Then visual interactive simulation. So I was talking about the initial, where you could see on the TV, like for example, some accident is happening, or there is something called as air crash investigation. So they make the simulation like, okay, the plane was moving like this, then suddenly this was the issue, and like this it happened. Okay, so that is like after gaining the information that it happened like this, they have done the simulation. But in general, like before the happening of any incident, they will imagine that it may happen like this, and they'll give that particular input to it, and they'll check like what will happen later. So that is the visual interactive simulation. Like for example, a dam is there, and suddenly if it breaks, how the water moves. Okay, or like for example, take go before the building of the dam, like there's a proposal of building a dam here in a particular place. So if they build a dam, how much area will be submerged? So again, this is a simulation. Okay, or again in the dam situation only, if there is too much of rain, if there is no rain, if there is normal rain. Okay, so how will this particular thing works? So I had seen a simulation a few days ago, like in China there was a huge flood that was there, and it was about to collapse a particular dam. So that was a very big dam, and there were small dams after that. So a simulation was made, and it was shown like if that particular big dam was like it was collapsing, like what would happen, how the water would rush, in what amount of time. So how much time that particular smaller dams would uh, take the load, and then again they will fail, and which all cities or which all areas will be submerged, how many people are affected. So what are the areas still where the water level moves up, so which is the place where if you go you'll not be affected much. Okay, so all these things are simulated basic. So these are visual interactive simulation. Okay, then comes the business games. Okay, so again, like for example, if I give you example, like you might have played the business game. Okay, where you are having different situations given there, different points, pawns will be there, you are throwing the dice, go three steps ahead, then build a house and all. So this is a simulation where they are giving you an example or the feel of you doing a business, you building a house. So if somebody is there, like you say the house is there, then somebody comes into your that particular house, then you they should pay you rent. So just a feel of the real life is given to you in terms of the games. Okay, so even the business game is one of the example of a simulation. Okay, it's a simulation where they're giving you, so you are not basically building, you are not doing a business, you are not flying to a particular place, you are not buying something. Like for example, places are there, like Darjeeling is there, this is there, that is there. Okay, so many places are there, so many colors are there, and to build a house you need to pay so much, to build something else you need to pay so much. So if somebody is coming and staying there, so build a hotel, so this much is the rent they'll be paying you. So all these things, they are basically simulations. Okay, so business games is also like that. So business game simulation model involves several participants who needs to play a role in a game that stimulates a real life competitive situation. So how it will help, what are the advantages of it? Participants learn much faster. Participants learn much faster, and the knowledge and experience gained are more memorable than passive instruction. Like if you really play, if I just tell you, you will think of like, yes, I was playing like this, and you remember that particular simulation. But if I just tell you and you have not played, so you'll say, okay, what sir is telling, you may not understand it. Okay, so that is what is the use of simulation. Then complexities, interfunctional dependencies, unexpected events, and other such factors can be introduced into the game for evoking special circumstances. Like, for example, unexpected events in the sense you go to jail in that particular game, for example. So, suddenly that is an experience that you are in a jail. So, you need to give like certain terms and you may not play. Okay, something like this happens. So, those are the interfunctional or the unexpected events. Okay, then the time compression, that means allowing many years of experience in only minutes or hours. So you say I want to build a hotel. So there is a small hotel wala pond there, and you keep it. So you are just building a house. Just a second, students. I think some technical issue. I'll just check. Just a minute. Some technical issues. Till then, I'll fix it. I'll be explaining you. So about the real life business scheme. Okay. So that is not done in a computer, right? So that is not done in a computer. You're literally playing. There's a board, and there are so many things which are there. So many pawns are there. You are playing with your friends, three friends, four friends, five friends, whatever the number of friends are there. Okay, so those many friends will be there always. Okay, and you guys are playing, and at the end one person will be bankrupt. There is a bank which is working. Okay, so it will give you money. You are taking money, you are doing so many things over there. Okay, so these things happen. Okay, then corporate and financial simulations. What are these? The corporate and financial simulation is used in corporate planning. Corporate planning, especially in financial aspects. The models integrate production, finance, marketing, and possibly other functions into one model, either deterministic or probabilistic when risk analysis is desired. Like what this means is, like for example, you are going to integrate. Like for example, you want to buy a company. Okay, so how well your company and the next company that you are buying will work together if it is a similar company. Okay, like for example, a car manufacturer is buying another car manufacturer. So his system might be different, your system might be different, or your way of working is different, the other company's way of working is different. Now they have to adapt, or you have to adapt to them. So how are you going to manage it? So it's a big issue. So that's how they are basically planning. So the simulation is done in a corporate and financial situations. Like for example, like finance minister, okay, she is trying to come out with a bill. So like for example, some tax reforms are there. So suddenly if they change the tax rates and all, so how will the effect on the amount that is coming to the government? Okay, then how much as the particular person has to pay? So like for example, there was VAT earlier, now there is GST. So when GST was introduced, what was the difference? Okay, how different things change. So what all needs to be done? So they say prior the government might have should have taken certain initiatives to stop this. Okay, like for example, at the time of demonetization, if you see, the government should have taken this, they have done that. They might have kept money in the bank earlier. Okay, so so many things were told. So how will you know? Okay, how will you know? Because it was done, like I don't know, this is the first time which I am saying the demonetization. So nobody knew that this could happen also. Then many people did not believe when it was even telecasted, those who have not seen it personally. So suddenly the prime minister came and he told, okay, from tomorrow there is no 500 and 1000 rupee notes which will be working, or it will not be rendered as 500 rupees or 1000 rupees. So suddenly there was a panic. So people did not know what to do. So similarly, the government as well. So they might have thought whatever things they have thought, according to their plan, they have done some things. But it may work, it may not work, because nobody has done it earlier. Nobody knows. So those simulations they'll check. Okay, if I do this, this will happen. So who knew, like people will be running around, there will be no money in the ATM, and so many things. Okay, so again, it will help people to understand how the situation will be. So this is so complex. How big our country is, how big the economy is. Suddenly you are withdrawing huge amounts of money, like 500 and 1000 rupees. Okay, so what would be the effect? So later on, they should have thought everything and they should have done it. Okay, so this is where the simulation helps. Then steps of simulation process. So there are different steps in the simulation process, like the identifying the problem. Like I told you, demonetization. So it was a kind of a problem which was identified. Now we need to put, next step is the identify decision variables. So which are the variables? Performance criteria and the decision rules. Like for example, take you are in a company, okay, and you are taking care of the inventory. Okay, so to know the variables, like how much per day is the requirement, okay, what is the lead time, if I put the order today, in how many days or how many hours I'll be getting the product to me, okay, and how big is the product, so do I have any place to store the product if I order more, okay, so all these things are the decision variables. So based on these decisions we are taking the like not decision, based on these variables we are taking the decision. Okay, like for example, one more thing is what do you call, how much quantity is required, one. Okay, so how much lead time it is required, then how much of quantity you keep it as reserve stock. There is something called as reserve stock. Okay, like suddenly it will, you cannot order after everything is gone, because the production will stop then and there because of lack of the parts, spares basically. So there will be something called as safety stock. So as and when it hits that particular point, so the order should go and it should take so many days, and the product should be replenished in the inventory. So those are the decision variables. Then construct a simulation model. So what is a simulation model? So what all things go into this particular thing, like if how to put an order. Okay, first I'll go and check the inventory. Should I go physically and check, or will I get to know it in the system? Okay, then if I order, like how to order, will I call, will I send a purchase order, okay, or will I call a tender to get the products? We never know, right? So this is one of the way. Then how the product will come to my premises, will I should go and buy, get it, or will the the seller will send it to me directly to my premises, how it is. So these are some of the things which are there just for getting the putting the order and getting the material. Okay, so these all things are inter related and interdependent. So that's how you need to construct a proper simulation model, then validate the model. So there are two things, one is the internal validity and the other one is the external validity. Internal validity means whether all the parts, like I am sending it today, so will it go to so many people, there will be deadline for sending the what you call quotations. Okay, so how much they are charging to do the work for me. Okay, then how much time I require to check whether the different orders which I am getting, like for the quotations. So different quotations, like which is the amount, whether the technical things are correct or no. So all these things. So these are interrelated again. So this is internal validity. External validity, whether the system looks proper. Okay, so this is what I'm talking is internal validity. Then external validity in the sense, if you are doing some particular part, so whether it is looking exactly, this is the external validity, exactly as my system, you need to basically replicate the system. Okay, so whether it is exactly looking like the system that I am working on. Okay, so this is the external validity. Then design the experiments. That means, like for example, you are testing a rocket engine. So like it is made for like for example, generating thrust of 500 kilonewtons. Okay, just an example. Don't worry about the numbers and what are they. That means the force that which it pushes the air down and it moves up. Okay, so if I change, like for example, if I just send half the fuel which I would be sending otherwise, so how will it work? I'm just sending half the fuel. If I send 30% of the fuel, if I send 100%, if I send 150%, if something happens, there is a what do you call, uh, a valve which is not functioning well, okay, which sends some coolant or something. Okay, it has to be stopped, but I cannot stop it, but something is going. Okay, how will that thing work? Okay, these are some of the design experiments. Then run and conduct the simulation. If this happens, what will happen? Okay, so for example, if I send 120% of the fuel, instead of sending 1 liter per minute, I am sending 1.5 liters per minute into the burning chamber or the engine, I'll call. Okay, so how will this particular thing work? Okay, will it explode? Will it give more thirst? Will the system accommodate this extra fuel? What will happen actually? So we never know, right? So we are making those things here. So I don't know to make know or how it will basically look at. Okay, so if I do it, how will it look? So will the system burst out? Will all the parts like break, or it can sustain that much of amount of things? Okay, so we never know. Then is this simulation process completed? If yes, examine the results and come out with the best course of action. So you are taking the decision here. Okay, so examine all the results. Okay, then if no, if it is not completed, check the side one here. So modify the model by changing the input data. So if you want to change anything, any system input data you want to change, so do those things. Okay, then again construct the simulation model, validate again. This particular cycle continues, and at the end, if you see, then examine the results and select the best course of action. Like for example, you might have heard of artificial intelligence. So what is this artificial intelligence? In the sense, it will not it will not come out knowing everything. So what it does is, it makes the simulations, then it will learn. Okay, like for example, one of the simulation you might have played this, the dinosaur game. When internet is not there, if you start pressing the space bar, okay, there is a dinosaur which comes, then you need to jump around. So there was a program, okay, the AI, it was like trying to learn. So people wanted to make that particular system learn this particular game. So initially what it did, it just went and it hit the this one, the first initial stack. It got out, then it started jumping. Then as the stacks are forward and backward, like the distance is different, so it the system should know like how to jump, how far to jump, and all. Then there are some different crows coming. If you hit the crow also, you'll die. Okay, so the same thing, the simulation will run like thousands of times, and the system will learn, and it will happen in minutes or hours. Okay, so if you start playing it, you may take days or months or even years to complete the whole thing or learn the whole thing, but the system can do it in matter of hours. Okay, so that is why the simulation is very very much important. Okay, so these are the steps of simulation process. Like, then coming to advantages. So we basically know all the advantages we just saw. Like, too much of work could be done in a smaller amount of time. We are saving a lot of money. Okay, like I told you about rocket engine. So we cannot build hundreds of rocket engine just for testing. Okay, so it will cost us to a very large number. So that is one of the things. Then sensitive analysis of complex systems can be done. Okay, simulation experiments are done on the model, not on the system itself. So this is just a model replica, okay, of the model, so that too much of money or too much of time and too much of other resources are not consumed. Okay, then simulation can be used as a pre-service test to try out new policies. As I told you, like the demonetization. So what happens if I do this? What happens if I change something? Okay, how the reaction will be from the public? Okay, how the system has to be changed. If I, for example, systems, in the sense the computers or the softwares which the government officials used to use. So earlier VAT was there, now GST. So everything has to be changed, right? Everything, the calculation, the system, the software, everything has to be changed according to the new rules. So they need to be very cautious. Okay, it is the remaining tool when all other techniques become intractable or fail. That means the last resort also you can call. Okay, so if nothing is working, you can check it on the simulation what could work. So that is the remaining tool. That is the advantage of simulation. This, then disadvantage of simulation. So sometimes simulation models are expensive. Sometimes, like for example, you do it on a computer, as I told you, like simulation of breaking of a dam, everything has to be set up, the graphical things have to be done. So it takes a lot of time and it is too much expensive. Okay. Then here they are given the example of corporate planning model may take a long time to develop and may also prove to be expensive. So it is trial and error approach. Okay, you should know like, okay, this much. Like for example, I gave you the rocket engine. Like I'm sending 1 liter. Okay, I'm sending 1.5 liter. I'm sending 30% or I'm sending 120%. So as much we know, only we can do it. So it's a trial and error things where we are knowing what happens. Okay, so it means it does not generate optimal solutions to problems. You can just know what is happening. So it will not tell you this is correct or this is wrong. It will work as per you have told it and as per your inputs. That's all. So each application of simulation is a ad hoc to a great extent. That means it uh, at once it happens. Okay, at once it happens. That is what is ad hoc. So it is not planned. Okay, it is just happens as and when you give the input. The simulation model does not produce answers by itself. The user has to provide all the constraints for the solution that he wants to examine. That means Just like that, it will not give you answers. You should put each and everything in place. You have to give each and every information that is required to get the answers, then only it works. Okay, so these are the disadvantages. Then we are coming to Monte Carlo simulation. I just told you in the beginning itself, there is a simulation called as the Monte Carlo simulation. Okay, so we'll see what is Monte Carlo simulation. So it's a technique that involves conducting repetitive experiments on the model of the system under study. Okay, repetitive experiments. So basic simulation they are telling you. So there is an model which you have already made, or a system of model you have already made, where we are conducting repetitive experiments with some known probability distribution. Here probability is important. It's a probabilistic function. Okay, there are some probability involved, like what is the probability of raining now, or raining in 1 hour, 0.2, 0.3, 0.8, we never know. So that is the probabilistic model to draw random samples or observations using random numbers. So here the term random numbers is very important. So just like that, you cannot say that I'm sending, like for example, it will rain now. Okay, there are 100 people who will be drenched, or they'll get wet. Okay, it is just a normal number. Okay, so they take those particular random numbers and try to test. So random number is very important. Okay, so here random numbers are already given, okay, in the question for you to use it and solve the or find the solution of the problem. So if a system cannot be described by a standard probability distribution such as normal, Poisson, exponential, gamma, etc., if we cannot find out the answers with this, an empirical probability distribution can be constructed. Okay, the Monte Carlo simulation techniques consist of the following steps. So these are the following steps. First, setting up a probability distribution for variables to be analyzed. Okay, like probability you might have seen the 0.1, 0.2, 0.8, 0.15. So that probabilistic distribution of variables has to be given. Okay, then build a cumulative probability distribution for each random variable. Cumulative probability distribution. So you have to go on adding. So you should know at the end you should get 1. Maximum probability is 1. Then generating random numbers and then assigning an appropriate set of random numbers to represent value or range. Okay, here range has to be made and we need to generate the random numbers. So don't worry about it, how to do and all. So in the problem, it's already given. The random numbers are already given to you. We need to take those and we need to make the range or the interval. Okay, that interval has to be made for each random variable. Then conducting the simulation experiment using random sampling. Then repeat step 4 until the required number of simulation runs has been generated, designing and implementing a course of action and maintaining control. So whatever you have seen now, so we'll be looking at with the example, with a problem. So you'll understand it properly. Okay, so this is setting up of a first thing. Okay, so we are going to study the Monte Carlo simulation method. Now coming to a problem. So what is the problem here? So before going there, so some of the places where this is used. So in inventory, in finance, okay, in hospitals, okay, or in medical things, in airlines, it is used in most of the places. Okay, so some of the problems they are asked to do it here. So in this case, we are taking a company which manufactures, okay, a manufacturing company, and some inventory, some inventories are there, then some what do you call uh, supplying parts or inventory control. So those kind of things are there in this particular problem. So we'll look at it. What it is: a company manufactures around 200 mopeds. Okay, two wheelers. You can take a small moped like TVS. You might have seen TVS Ultra. Those are called as mopeds. Okay, a company manufactures around 200 mopeds. Depending upon the availability of raw materials and other conditions, the daily production has been varying from 196 to 204 mopeds. Okay, so what is happening here? The production is varying from 196 to 204 mopeds, whose probability distribution is given below. So from 196 to 204, they have given the probability, that is 0.05, 0.09, 0.12, 0.14, 0.20, and so on to 0.06. So the probability is given. Then what is asked? The finished mopeds are transported. So here is the transportation problem. In the sense, the problem is the transportation. So what all they have asked? The finished mopeds are transported in a specially designed 3 storage lorry that can accommodate only 200 mopeds. So this is important. So the lorry can take 200 numbers of mopeds. So using the following 15 random numbers. So I told you that it will be given in the problem itself. So the random numbers they have given here. These are the random numbers. Okay, till here is the random numbers. And simulate the mopeds waiting in the factory. Like if you want to transport it, the vehicle only takes 200 mopeds. Okay, so what they are asking, what will be the average number of mopeds waiting in the factory? That means more than 200. When are you producing it? Then what will be the number of empty spaces in the lorry? So if you produce less, like less than 200, so how many are there here? See here, 196, 197, 198, 199. Okay, till here if you make, so there will be here one will be empty space. That means one moped can be accommodated, but it is not there because you have not produced. Here are two, here are three, and here four. So per load you can have up to four empty spaces. So they are telling what will be the number of empty spaces in the lorry. They are asking you. Then what will be the average number of mopeds waiting in the factory? That means more than 200. If you see here, so 200 it will be 0, it will be 1, 2, 3, and 4. So how many mopeds you are basically making more than the transportation possible? So that is what they are asking you. Okay, so what to do now? So the important thing is production per day they have given, probability they have given, and they have given the 15 random numbers. So the number of random numbers they have given, it will be for those many days or hours or whatever. So in this case per day they have given. So you want to simulate it for 15 days, 15 days, and the production is from 196 to 204. So now let's see the solution. So first what we need to do? So first we need to do production per day and probability has to be written. Okay, then if you see here, so cumulative, there was some word here somewhere. Generating random, yeah, building a cumulative probability distribution. So that is what we are doing now. So probability is a cumulative probability. So everything is written from 196 to 204 is written here under production per day. They have written here. Then for the probabilities, they already given here. The probabilities are here. So the probabilities are written again in front of those particular production per day values. Then cumulative, then we have to go on adding these. So 0.05 initially will be 0.05, then 0.05 plus 0.09 is 0.14, then 0.14 plus 0.12 is 0.26, 0.26 plus 0.14 is 0.4, 0.4 plus 0.2 is 0.6, then 0.6 plus 0.15 is 0.75, and so on it goes up to 1. Okay, this is the cumulative probability which you have calculated. Then we have to generate the random number interval. This is important. Okay, how we need to do it? Listen carefully. Random number interval. So it has to be less than this particular value. Okay, it has to be less than this, one less than this. So it starts from 0, right? The probability starts from 0 and ends at 4. So you need to end up at 100. Okay, so if you take into 100, so it is 5. You have to move the value front. So 0.05 into 100 is 5. So this will be less than 1 less than 5. So this is 4. So similarly here if you see, it will start from 5 because up to 4 it is done here. Up to 5 is here, then here it is 14. So it will be up to 13. The next it starts at 14. Here it is 26. Then it will come to 25 here, one less. Okay, then here it is 40. So it will start from 26 and end at 39. So next here I am having 60. So 59 will be here and it will start after 39. That is 40 to 59. So 59 is here. It will start at 60. Then less than 75. That is 74. And so on till last. So it will not come to 100 because one less you should be there, right? It is up to 94 to 99. Right? So this is the end. Till here we need to do. This is the random number interval. Now there is one more. Okay, you can copy this later. Don't worry about now. You can check out this particular video. It will be uploaded. So you can take it and you can write it later. So first listen, leave everything and listen how to solve the problem. Okay. So next, if you see, so there were 15 numbers which were given, random numbers. So these were 15 random numbers. If you see here, 82, 89, 78, 24, and so on. So here if you see here, they have written 82, 89, 82, 89, 78, 24, and so on. There are 15. Okay, there are 15 here. So number of days, I told you, as many random numbers they are given, it will be for that much of duration. So here duration is measured in days, so it is 1 to 15 days we are basically simulating. Okay, so production per day 202 203. How we have got this? Using this particular random number. So first random number is 82. So 82 comes where? 82 comes between 75 and 85. So 75 and 85, what is the probability? Sorry, what is the production number here? Production days 202. So that is what they have written here, 202. Okay, so next I'll just remove this so that you'll understand better. Erase. Okay, so next value is 89. So where is 89? 89 comes between 86 and 893. So 86 and 93, how much is the value? 203. So this is 203 is there here. Then 78. So if you see 78 is between 75 to 85. So what is the value? 202. Okay, so 202. Then I'm having 24. So if you see 24, where it is? 24 comes between 14 and 25. So what is the value? 198. So we are rating 198 here, and so on. We are finding out the production per day. Okay, so we are finding out the production here. Next, if you see number of mopeds waiting. So when will the waiting happen? When we are having more than 200 production. So when we produce more than 200 numbers, then only the mopeds will be waiting. Okay, so empty space when it will be in the lorry, when we are producing less than 200, at that time only we will be having empty space. So first one is 202, we are producing 2 extra, so there will be 2 waiting. So here it is 203. Okay, 203 is there. So 3 plus 2, it is 5. Okay, so 5 plus 2 again 7. 7 plus, and so on it goes on. So as we are producing more, the waiting time only will be there for the mopeds, okay, per day, and there will be no empty spaces because we have already filled, and there is extra which is waiting for me. Okay, so extra there is there and it is waiting for me. So for that we cannot do anything. So there will be mopeds waiting because the maximum number of mopeds goes into the truck is only 200. So anything less than 200, then we will be having empty space. So if you see here, 196 is there. So 196. Okay, so there are 190. So random number is 04. Okay, 196 mopeds are there. So there will be some empty space. Okay, then 198. So 200, how much it is less? It is less by 2. Okay, it is less by 2. So no waiting, no waiting here. So I am having 2 numbers of empty space here. So why there is no empty space here? Because earlier you had something, right? Extra. So that goes here. 96 was there, and 96 plus 4, it goes here. So there will be no waiting time. So here 198 and 2 are less, but there is nothing here left. So 2 will be empty. Then I'm making 200. There will be no waiting. There will be no space. Then I'm making 202. Then there will be 2 extra because 2 is extra. So before I'm not having anything here. So I'm not having anything here. So 2 will be extra and there is no waiting space. 199. So there is 2 here. So 2, 1 will go here. So there is no waiting, and sorry, there is no space in the lorry because I'm taking 1 from here and only 1 is left. Right. So 200 if I make, there is 1 left and 1 also will be left here because 200 I will make, but 1 was already there, right? So that 1 will be here and there will be no waiting. So 197 if I make, 3 I am keeping empty, 3, but there is 1 here extra, so I'll take it here and only waiting, the extra space will be 2 generated. So this is how we are basically making this for 15 days. For 15 days, taking random numbers, we are finding out the production per day based on the random number interval here. Okay, with that we are trying to find out how many mopeds will be waiting in the factory extra produced, and how many will, if there is less production, and how much of extra space is there in the lorry. Okay, if the number of production is less than 200. So that is what is given here. Okay, so this is the uh, proper answer. Okay, number of mopeds waiting and the empty space in the lorry. So on what days there will be empty space and what days there will be extra number of vehicles it will be waiting here. Okay, so see, they have asked you for average number of mopeds waiting in the factory. So average number of mopeds waiting in the factory is, total number of days is 15. Okay, then how many are extra waiting? So you need to add those. So that is 2 plus 5. Here see, 2 plus 5 plus 7 plus 5 plus 5 plus 6 plus 4 plus 4. Coming here plus 2 plus 1 and plus 1. So that is what is written here. So it comes to 2.8. So in general, if you see 2.8 vehicles, so it is almost near to 3. Okay, so almost 3 vehicles per day in average will be having the waiting period. Okay, they'll be waiting in the company itself. So if you see the average number of empty spaces in the lorry, so see here 2 plus 2, 2 plus 2, only 4, divided by how many days? 15. So 4 divided by 15 is 0.27. It's almost 0, you can say, or if you round it off because some value is there, it will come to 1. But if you see, there is many places there is no uh, space in the lorry, so you can round it off to 0 itself. So if you don't round also, it is fine. So on an average 0.27 space is empty in a vehicle, and 2.8 approximately 3 vehicles are waiting in the factory per day. Okay, so this ends the problem here. So what simulation we did? We did the simulation for 15 days taking random numbers, and we knew the production. Okay, we knew the production. The production would be from 196 to 204 using this information and the probability of that happening. Okay, we took the cumulative probability, then we came up with the random number interval. So in which interval it falls. Then there were random numbers given to you for 15 days. So those numbers are put over here. Then where it falls, based on that, the production day we have found out. Based on the production, we found out how many mopeds will be waiting, or is there any empty space in the vehicle. We know that vehicle will have 200 numbers of mopeds which it can carry per load. Okay, so are there any times when the load is less? That means empty space is present in the vehicle, or because 200 only can accommodate, only 200 can be fit, and extra will be standing in the factory itself. So will that happen here? So they are asking how many mopeds will be waiting and how many spaces will be there in the lorry. In average also they have asked, so average it is 2.8 and 0.27. So on a daily basis we have calculated here, it is 2 5 7 5 5 6 4 4. So these many vehicles will be waiting in the factory. Okay, and till then, so when they are waiting, in the sense after filling of the truck only, it will waiting, they will be waiting, right? So there will be no empty space in the vehicle. So when it goes down, and if there are no waiting vehicles, then only there will be empty space. So here 2 and 2 only is there. So any difficulty here, students, in understanding? So similar problems will be there. Like for example, here waiting is there. No, similarly, there is a doctor. Okay, for example, in terms of medical, I'm giving you the example. There is a doctor who has few patients. In the sense, on a regular basis, if you see, there will be generally from, for example, 20 to 35 patients per day. The doctor looks at. Okay, now this is per queuing. Like when he comes in, on an average, he takes around 30 minutes per patient. Okay, so how much the patient has to wait? Okay, so similarly here, number of waiting mopeds. So how much the patient have to wait? Okay, and will the patient, will the doctor be waiting? In the sense, is the doctor having any extra time? Because if he finishes the patient fast, like for example, I gave you half an hour. So first patient, if he finishes in only 20 minutes, so he'll be having 10 minutes extra. So there are some assumptions here. Based on those assumptions, we say that, as we say, half an hour is the time taken, average time taken for a particular doctor to see one patient. Okay, so based on that, I'll be giving the number next. Next person will come at half an hour. Like for example, if he starts the pharmacy or the equipment or the what you call the hospital starts at 8 p.m. Sorry, 8 a.m. in the morning. That means after every half an hour, the next patient will come. The first patient will come at 8 o'clock. The second patient will come at 8:30. Third patient will come at 9 o'clock, and so on. Okay, and it depends on the type of what you call the work the particular uh, doctor is doing. For example, take dentist itself. So it's just an oral exam. It may take 10 to 15 minutes. Okay, or if it is only fitting a crown, okay, so it may take 1 hour. So different works will take different amount of time, and based on the random numbers we are trying to find out how much of what you call waiting time a particular person has to wait, like the patient has to wait, and is there any ideal time for the doctor. So is the doctor waiting between patients? Okay, so this is one of the example where they could ask you, okay, so how many people are waiting, like how much of waiting time per patient will be there. Okay, and average also, if they make it total number of waiting time divided by total number of patients, so average waiting time will come. Then is the doctor waiting, like in the sense, is the doctor having some time for himself? So it may not be there, it may be there, and average you could take something like this. So these are some of the problems, Monte Carlo problems, okay, which are given to you. Okay, so in the examination also, I mean in the IA, you might get certain problems like these. Okay, be prepared. And in the earlier case, okay, there also you might get some problems. So we have solved one problem there and one problem here. So similar problems are there. Okay, there if you see 2 cross 2 or m cross n or m cross 2 or sorry, 2 cross n or m cross 2. So these are some of the values which you are getting, in the sense the matrix you will get. So based on those things, based on where you can end up, like 2 cross 2 if you are ending up, and whether if you get that saddle point, so the sum ends up very easily. If not, you need to use other methods, okay, and solve it. Okay, fine students, so we'll stop for the day. Okay, so be prepared for your internals, and again I'll be repeating the uh, syllabus is module 4 and module 5. So prepare well and attend the examination. All the best students. So this ends up the overall syllabus for your operations research subject. Okay, okay students, prepare well for your internals and all the best. We'll end the class for today.
Thank you, sir.